Hello everyone and welcome back to another video. I'm your host Stefan. I'm a geologist and geophysicist, and today we're going to explore the connection between earthquakes and the Schumann Resonances, and we're going to look at how the Schumann Resonances actually predicted that earthquake that happened in Turkey and Syria with some of these preemptive ELF signals that we can see there. So this video started just as a Schumann Resonances video. I was going to look at this arc of energy there. When then I realized that this is actually happening at exactly the moment of the Turkey-Syria earthquake, the magnitude 7.8 that hit on February 6th. So I lined it all up. This is the main slide we'll be looking at. We'll be looking at these frequency waves that we saw preceding the earthquake, some really interesting and unusual energetics. We'll be going into depth. This is the location of that Turkey-Syria earthquake right there. This is the moon. We'll be talking about the moon and the sun positions. It was just slightly off of a new moon at the time, happening exactly during the nighttime window. So a little bit of energetic speculation here. There's a lot that we don't know about the Earth, and we'll be digging into some of those dark and gray areas. And I'm currently reporting on this from Egypt, so I apologize if this video is a little noisy in the background. I'm next to the pyramids right now. This was taken last night. These are, of course, the pyramids at Giza. And in this video, we'll be revealing dimensions of energy that you might not have known and that are just now beginning to come into the public awareness. There's been a lot of research done on how electromagnetics influence earthquakes and how there's preemptive electromagnetic signals generated by earthquakes, both before, during, and after earthquakes, and how things like solar activity can change earthquake activity. So we'll be talking about how the sun, earth, and moon together alter Earth's telluric electric currents and how those trigger earthquakes. And we'll be doing that by primarily looking at Schumann Resonances data. So if we go back here, this is the Schumann Resonances. This is a spectrogram of data. Basically this is electromagnetic energy. This is light energy, just the same as the visible light that you see. So the difference is that it has a much lower frequency. This is 0 frequency there, and then this is 40 there, and then this is time. This is 0 AM in Tomsk, Russia, where this is basically recorded. So that's UTC plus 7, and then we have a 0 again there, and I lined this up to be UTC, so at 8:17 in Tomsk or at 1:17 in the morning for Turkey-Syria, or maybe UTC morning, we have the earthquake strike right there. And we can see that there's this big arc of energy that goes up through the ELF spectrum, starting here at about 25 Hertz, and then going through mode 3, the Schumann Resonances, touching nearly mode 2, and then back down. Okay, but before we really dive into that, you might not know, what are the Schumann Resonances? The Schumann Resonances are waves of light energy that exist near the infinite wavelength of 0. 7.8 Hertz is the first mode with a wavelength equal to the circumference of the Earth. And the reason why they're called resonances is because they are stable standing waves that the Earth has in between the Earth's surface and the ionosphere. The Schumann Resonances actually, these waves of energy actually exist in the ionosphere. They've been measured out beyond the ionosphere into space, and you can measure them in the Earth's surface as well. So they're really ever present throughout the Earth across space-time. But what's notable, as you see here, is that they're stronger than the rest of the ELF energy near them. ELF standing for extremely low frequency. So you can see this is like 10 Hertz right there, 12 Hertz. And it's a darker blue. It's a lower power than the second mode at 14 Hertz there. This is the foundational mode at 7.8. And then we have 20 Hertz. This is mode 3. Reason why mode 3 has such a strong line there is because that mode is stacked on top of a man-made 20 Hertz harmonic from the power grid. So you're basically boosting the signal up beyond normal artificially. Then mode 4 is at 25 Hertz. And then we have mode what would be 1, 2, 3, 4, 5 at 33, and then 39, and so on and so forth. This only goes to 40. This is one of the main spectrograms that's publicly available, which is why people use this monitoring station out of Russia so much. And the nice thing about the Schumann resonances is that because they are present across the Earth, and because light travels so quickly, you can measure them basically anywhere and get a pretty good picture of what's happening on the Earth. So certainly measuring them near the location of this earthquake, like let's say there was a monitoring station right here, would have been preferable. And there are universities that do have very close monitoring stations to this. So I'm interested to see the research that potentially comes out about this. But Tomsk being over here or so is actually not too far away. So that makes this data set pretty good. Now, what we see in the Schumann resonances here that's really notable, a few things, is that we have first these waves of frequency increases in mode 3. This is 25 hertz energy. This is, of course, an extremely long wavelength, not the same wavelength as the circumference of the Earth. That's the foundational mode at 40,000 kilometers. But at 25 hertz and the speed of light, it's a very long wavelength. And this wavelength has been tied to earthquake activity countless times. Countless observations have been made. That's been published in a lot of different research papers, which are very interesting to read. So we see these interesting cyclical waves of frequency increases in mode 4. Here you can see the scale. So this goes from 23.7 hertz up to 25.9. And it's about 24 there, going up nearly to 26. And they're about a day long too. So we have this first one here. And because this goes frequency 0 down to 40, you can see that it actually kind of drops like that. That's a frequency increase when it goes down in the spectrogram there. That's mode 4, goes like this. And then we see this longer wave of frequency increase in mode 4, directly preceding this earthquake. Again, I put the earthquake time right there, and this is the energetic burst that resulted from that earthquake. But we actually had preemptive signals too. We had these harmonics that showed up. And I wish I had a better image of the data. I was wondering if I should save the image when I first saw it, but I decided not to. I should have done that. These are some also energetic arcs that occurred through the ELF spectrum. We see one there at about 36 hertz, but then we also see two here very nicely right in that earthquake ELF energy zone. So this was on May 2nd. This is before the earthquake actually happened, 4 days before, and then we see this repeated again at the exact moment of the earthquake, and then going for about almost, let's say about 6 hours after that earthquake. And we can see it actually has harmonics here, very faint, but you can see the trace of that there, the other parabola. Same thing here. You can see the higher gain there. So it goes up. And then most clearly is this upper harmonic there, which is part of this burst of Schumann resonances activity that we saw immediately after that earthquake. You can see the line right there and immediately increase. So these waves though, these frequency waves are really interesting because they're a very long time span. They're 20, like this one is like nearly 24 hours in length, actually even longer if you go from this low to this low. And right when this wave comes to a final like trend end, like right here, right at that 8-hour mark for Tomsk, Russia, or again, this is about 1:17 UTC, we see mode 3 has a big frequency increase, big frequency volatility, almost like a heartbeat, a pulse go across it. And that is right when that earthquake strikes. So there was some energy dynamic that the Schumann resonances captured that was basically causative of this, or causative with this earthquake. What exactly triggered this earthquake? We're going to speculate a little bit into that, or at least I'll give you an idea of something that may have contributed to that earthquake. But what we know is that there was some culmination of energy at that location space-time strong enough to displace the faults and the hard rock and the ground. Everything that we think is solid suddenly got displaced, was able to rupture quite significantly, magnitude 7.8, same number in fact as the foundational mode of the Schumann resonance here at 7.8 hertz. So a little bit of an interesting coincidence. And everything was then able to slip and move, and that required a huge amount of energy to create that initial atomic structural breakdown and then physical displacement. So Schumann resonances captured the energy beam that was sent out. After that, you can see this again, this energy went all the way from mode 4, nearly touching mode 2, and then we're going to talk about why that's significant and where this may go, because there are some predictions for the future that are based on observations that we have of how the Schumann resonances basically naturally interact with each other and how they naturally manifest. And if we go here, we can start to explore what may have triggered this earthquake. Now, we see here the daylight and nighttime boundary. So I put that in over this map, and we can see all the historic seismicity with the white dots there. These are the plate boundaries. So we have the Africa plate, we have the European plate, the Middle Eastern plate might be called something different, Eurasia plate. And if we zoom in here, we'll see the epicenter and the corresponding outlying shake zones of intensity as plotted by the USGS. The star there is the exact epicenter. And we see that there is clearly some sort of fault there, because you see the orange is highest along this line. And that is actually a triple junction between these plates. So this plate, and this plate, boom, there's your triple junction. Very, very notable spot, because that's accommodating stress from 3 different areas at once. And what I found very interesting is that this all lined up with the moon. This is the moon here. The reason why it's black is because we're looking at it from space, and since it was a full moon, this side right here would have been black to us, you know, the dark side of the moon. But I put these rays of light coming out, and the reason why that's significant is because the Sahara here, if you look at the Earth, the Sahara is one of the most resistive places on the planet. By resistive, I mean not electrically conductive. Ocean water here, this is all very conductive. It's saline, has lots of ions and salts dissolved into it. So everyone knows not to drop your toaster in the bathtub. And then you have areas where there's vegetation and water and moisture. Those areas are conductive. You have a lot of stronger tellurics in the surface there. You see all of Europe here is pretty green. And there's other places that are also desert. I mean, this kind of extends the Sahara out. But in terms of one contiguous area, this would be the Sahara. The only place that could potentially be more resistive is Antarctica, because it's covered in ice and highly reflective. So it's bouncing a lot of photons back out to space, which is what determines conductivity in many ways. And the Sahara here, remember, is the size of the United States. So it's a very, very large area. And right when the moon, the nearly full moon was on the 5th, earthquake happened on the 6th, less than 24 hours later, right when the full moon was over, directly dead center over this highly resistive area, during peak nighttime, this was exactly at peak nighttime, when the energetic currents of the Earth would have been the least and the quietest for this part of the world. Right when the full moon hit that area and shined a lot of light and energy into the Sahara, then there was some sort of displacement here. You know, we had the large magnitude 7.8 earthquake, and potentially the full moon helped overload that fault zone there through some energetic current that we currently don't know that much about, if anything, and then that accommodated the slip. Now, the Sahara is very resistive, but underneath it, we know it has very vast aquifers, huge aquifers, and we also know that the Sahara has a lot of salt deposits on top. So it's possible that these aquifers, well, we know they have various levels of salinity too. So these vast aquifers under the Sahara are conductive, and they could potentially have their one layer and route of how light energy could flow from here to there. And we didn't see this earthquake pop off here or there. This could have gone in many different directions. Whatever the reason is, it seems that the most efficient route for that light, the areas of potential were, if there was a buildup of light potential here, electromagnetic potential, field potential, then it kind of shot this direction. At least that's my hypothesis. There's a lot of evidence showing that strong telluric currents, if they overload a fault zone, are able to make circuit closure, then they can rupture and create that earthquake. And that earthquakes are often preceded by electromagnetic activity in the ELF and ultra low frequency bands of the light spectrum. So that's, we see these preemptive signals there, which were fairly weak, but very weird. I've never seen those before. I've been looking at this for a few years now. That was certainly a new phenomenon to see that live. And now that it's happened, I have a better understanding of, okay, that might mean that we have an earthquake coming in, because we saw this happen exactly with that earthquake. Now, if we look at the horizontal magnetic components and the vertical component, this is the electric component, we see some interesting things here. We can see those waves, those frequency waves, show up as higher magnetic resonance there in mode 4, that 25 hertz mode. We see an increase in magnetic qualities and then a decrease. So we see waves in mode 3 in the magnetics, whereas we don't see that in the frequency because of the power grid noise it's sitting on top of. But we do see it in the magnetics. So we see waves there too. Mode 2 stays quiet at 14 hertz. Mode 1 not doing much. If we look at the spectrogram, mode 2 has actually been very strong. And this continues a trend of energy being loaded into mode 2. Because fundamentally what this earthquake did is it moved energy from mode 4 to mode 2. We see it really start to accumulate here afterwards and then there. I mean, you can see the strength of mode 2 much stronger than mode 1. Mode 1 is the dominant Schumann resonance. So the fact that mode 2 is stronger gives you an idea of what's about to happen sometime in the near future, which is that energy is going to flow from 14 hertz to 7.8 hertz. Now, if we look at our components again, we see that we get big increases in mode 2, and then we get here in mode 1 a sharp increase starting right at the beginning of this earthquake. Mode 1 now begins to have a very large increase in its magnetic qualities, and it hits a high there of 14.6, and then it starts to go down, and mode 2 woke up before that, and you can see mode 2 qualities drop right at about the same time that mode 1 really starts to charge upwards. So very interesting how it's almost like mode 2 kind of started to feed this way, and then at the same time this popped off and fed back up, and then mode 1 woke up, and lots of interesting interplays that are hard to fully unravel, but it's worth trying. Now, this is the vertical electric component of the electromagnetic field in the ELF spectrum, and we see that after this happened, and this is the new scale bar there, these are relative amplitudes, we see that after that happened, mode 2 became really strong. It went up to 7.5 there, and then also went, this is actually lined up for here, and then this broad peak is for here. So we see that it went up to 7.5 there, strong pop, and then we see that mode 1 and mode 2 start to have activity, whereas modes 3 and 4 at 20 and 25 hertz stay relatively quiet after that earthquake happened. So we have a increase now in energy, a continuous loading of energy into mode 2, that 14 hertz wave, and that leads me to what I think is going to happen in the future, which is we've had a continuous loading of energy into that band, and it's a very cognitive band. It's a low beta brainwave. These interact with the human brain. That's been shown. And beta brainwaves are associated with focus and with creativity and attention and wakefulness and things of that nature. So fundamentally though, energy resonates best in the 7.8 hertz band because that is the Schumann resonance that has the same wavelength as the circumference of the Earth. So it's just a better resonant combination. And at 14 hertz, it's losing energy a little bit faster than it would if it was in mode 1. So the fact that mode 2 has been so strong so far since the beginning of 2023, eventually what's going to happen is this energy will move from mode 2 into mode 1, where it will resonate better. There's a variety of energetic pathways that can accommodate that. The ionosphere takes a large role in that. Lightning can shift energy around. It produces Schumann resonances along with a whole bunch of energy in the light spectrum. Lightning is actually really incredible, and that it produces light photons at nearly all frequencies, going from almost close to 0 hertz all the way up to gamma rays. But when this energy from mode 2 going forward, looking forward, what can we expect? When energy is going to move from mode 2 to mode 1, we're going to see sympathetic nervous system activity finally get a break, and with parasympathetic activity rising as a result, because 7.8 hertz is connected to delta waves. These are delta waves and theta waves. Theta waves are 4 to 8 hertz in frequency, and alpha waves are 8 to 12 hertz. And these are the waves of creativity when your eyes are closed, when you're very relaxed. And what we're going to see is, with an increase of 7.8 hertz energy, a return back to normal Schumann resonances conditions, we'll see an increase in delta waves, new orders, creativity, and vivid dreams. I think what we'll see is there's going to be a creative surge amongst people. I think a lot of people are going to find that they're starting to have more vivid and interesting dreams. There's going to be a stronger connection to our subconscious and a less, a little bit of a pullback from the heavily cognitive and mental spheres that I think a lot of people are in right now. So this is a much different video than I initially intended to make, because I was originally just going to talk about the Schumann resonances, and then I heard about this earthquake and found the connections between them, and how really the Schumann resonances are a perfect platform for revealing these dimensions of energy that most people are unaware of. Now, if we go here quickly, this is something I just want to show you to kind of strengthen my case for why the conductivity and resistivity aspect of the Earth, Sun, Moon position matters. If we look at the sun here at the time of the earthquake, the sun was located over one of the most conductive halves of our planet. There's many ways you can cut our planet in half. If you look at how the light cut our planet in half, you get the day-night line nearly at the edge of Eurasia, and then you have Antarctica there, but it's almost completely ocean, which is highly conductive because of all the saline salt. Look at that. And then if we go to our nighttime side, where the energetics are the quietest, and because there's no photonic energy from the sun, or very little, well, there is, it's coming back from the moon, right? It's a full moon. We see a lot of land masses here. So those are all resistive. And then, of course, right where the moon was over the most resistive of the land masses, which is the Sahara. It's very dry, very little moisture. It's usually hot. Now it's during the northern winter, right? So this is like the quietest of the quietest conditions. And then through that, the sun pinged a signal off the moon through there that was clearly strong enough to pierce through that resistive landmass, and then it triggered an earthquake there in Turkey. Now, this is building up a field of electromagnetic potential on the daylight side. This is building up a negative field of potential there on the moonlit side, and then perhaps there's some energetic interaction that occurred between the two, which then was responsible for doing something here in Turkey. So just some broad strokes, things I find interesting. This is certainly, you can just think about this in terms of the electric fields of potential and how they would be based on just standard physics. And certainly this would have been a very, very, this would have been less conductive, this would have been more conductive, a big difference in the potentials that then triggered this severe movement of the Earth. If we look at the sun and moon position, we can actually see how the moon transited over the area. This is 3 hours before, that's at the time of the earthquake, and then that's 3 hours afterwards. So again, you can see how this is exactly in the middle of the nighttime. part, and there is the Sahara. It's right there lined up in North Africa. So if you like this video, I make more of these looking into the Schumann resonances. I hope you found this interesting. Definitely some very interesting things here. This earthquake energy is fascinating, and these signals there, potentially, if we had known more, if we better understood this, if people found this more of a priority, could have been a warning signal to the people of the area. There's a lot of information that we clearly just don't have yet. But with time, maybe earthquake prediction will be possible. So I suggest if you like the video, click that like button. It helps a lot. Subscribe to my channel if you would like to learn more about Earth and her energies, and also human bioelectricity and consciousness, because they all overlap. Thank you, evolution, for that. And leave your comments and questions below. Whether you have other ideas or some additional information to provide, that's always useful. So start a discussion there. My heartfelt condolences to everyone that's been affected by this earthquake. The rest of the world stands with you. We are all one. And with that, I wish you a great day. I'll see you in the next video. Ciao.